Hey everyone, today we're going to talk about polynomial factoring. Before I get into polynomial factoring, let's do a quick review. There are three ways to factor a quadratic. There's GCF, which always comes first. It's the one you always forget. There's simple quadratic factoring. That's what you multiply to make the last number and add to make the middle number. And then there's slide and divide. That's when the number in front is not 1. So let's talk about ways to factor polynomials. One way we do it is perfect cubes, and I have a little song to help you through that. Another one is called higher order quadratics. That's where the first term is twice as big as the middle term, so it looks like a quadratic, where it's twice as big as the one before it. And the last way is called grouping. So let's start off with the perfect cubes. This is for binomials that look like this, where you have a perfect cube and a perfect cube. Okay? And it doesn't matter whether it's plus or it's minus. I don't sing very well, but if you think about this as to the tune of Jingle Bells. Okay? Take the cube root square the first, multiply together and change the signs and square the last. I'm sorry, I don't sing very well. But these rules are the ones that you're going to have to follow. So let's take a look at this problem. These are two perfect cubes. It says, take the cube root, take the cube root. Well, what's the cube root of x cubed? It's just x. What's the cube root of negative 8? It's negative 2. Why is that negative 2? Because negative 2 times negative 2 times negative 2 is negative 8. So that's the take the cube root part. The next thing says square the first. So if I square this first thing, I get x squared. Multiply together and change the signs. So multiply together and change the sign. And the last one is square the last. What's negative 2 squared? It's positive 4. So that's how you do a perfect cube factored. Take the cube root, square the first, multiply together and change the signs, and square the last. Let's try another one. These are two perfect cubes. Sorry. Now they're two perfect cubes. The first set of parentheses is for take the cube root. What's the cube root of 8x cubed? It's 2x. Plus, what's the cube root of 27? It's 3. Why? Because 3 times 3 times 3 is 27. So take the cube root, square the first. This is not 2x squared, it's 4x squared. Multiply together and change the sign and square the last. So that's perfect cube binomials factored. Now somebody might say, Mr. Ratliff, this is a quadratic. Couldn't this factor further? You're right, it could factor further. But let me just give you a hint. Whenever you factor perfect cube binomials, they won't factor anymore after your song. Higher order quadratic trinomials. Some polynomials are written like quadratics, where the first degree is twice as big as the middle degree. In this case, we're going to factor like a quadratic. And then the new factors will have the same degree as the middle term, but you might have to factor further. Let me show you what I mean. Even though this is x to the 4th, this is still a quadratic. Why is it a quadratic? Because this is twice as big as this, and that doesn't have any power. So I'm going to factor it like a regular quadratic. I need two numbers that multiply to 15 and add to 8. Well, that's 5 and 3. But now I'm not going to put x plus 5 and x plus 3. I've got to match the middle term. X squared plus 5, x squared plus 3. If you wanted to make sure that this is right, let's distribute it back out. X times x, x to the 4th, plus 3x squared plus 5x squared plus 15. Oh look, that's x to the 4th plus 8x squared plus 15. Yep, it works. So, if the first degree is twice as big as the second degree, and the last one is no degree, then you can factor it like a quadratic. Will these factor any further? These won't. 4-term polynomials by grouping. If a polynomial has 4 terms, you can try to factor by grouping. It doesn't work all the time, but when it does, it's nice. We're going to group the first 2 terms and the last 2 terms together with parentheses. We're going to GCF each set of parentheses. If they have the same thing left inside, good, then we can do grouping. Put the outsides together with the insides. Let's try one. It's 4 terms, so let's try to group them. These go together, and these go together. What do these 2 have in common? X squared. If you pull that out, you have an x plus 3 left. What do these 2 have in common? A negative 4. Now be careful. If you pull a negative 4 out, you've got an x plus 3. Take a look at that. That's the same as that. So my insides are the same. Perfect. Then let's put the outsides together with the inside. Are you done? Well, maybe. Can this factor further? That can't. There's no squared. Can this? Yeah. What 2 numbers multiply to negative 4 but cancel out in the middle? Positive 2 and negative 2. Now I have factored completely. Always remember to see if you can factor further. Don't just stop after the first step. See if you can factor further. That does it for polynomial factoring. There's 3 types. There's perfect cubes, and you have a song to remember that. There's higher order quadratics, when the middle term is half as big as the first term. And then there's grouping, when you have 4 terms, put the first 2 and the last 2 together and see what happens. If you have any questions, come talk to me. Thanks, everyone.